This conference will now be recorded.
Right, let's start today's session. In the last session, we were discuss about database connectivity program using Microsoft SQL Server and using MS SQL. Using MS SQL as well as using MySQL we discuss. Okay. So today we'll see other concept that is called multi-threading programming. So multi-threading means at a time we can execute multiple programs so that parallel execution is possible in Python. Parallel execution means multiple programs we are going to run at a time, that is called multi-threading programs. First, let me show you what is multi-threading, what is the advantage of multi-threading program we'll discuss. Okay. So before going to discuss about multi-threading concept, and I need to talk about multi-tasking. Yes, multitasking I need to discuss. Generally, multitasking means what? At a time, we can do multiple tasks. That is called multitasking, simple logic. Okay, at a time, we can do multiple tasks. It's called multitasking. So let's look into multitasking. What are the types of multitaskings? How to work with them? We'll discuss now. So first, today topic is multi-threading. But here before that, multitasking, I need to explain what is multitasking. Multitasking means executing several tasks simultaneously. Executing several tasks simultaneously 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 is the concept of multitasking. Is called multitasking, we can say that. Is called multitasking. Executing several tasks simultaneously is called multitasking. Okay. Executing several tasks simultaneously is called multitasking. There are two types of multitaskings are there. Okay. So there are two types of multitasking concepts are there. What are that? One is process-based multitasking. Okay, process-based multitasking. This means multi-processing, we can say that. Multi-processing. This is also called as multiprocessing. Next one is thread-based multitasking. Thread-based multitasking. That means multi-processing. Multi-processing, we can say. Process-based multitasking, that is multi-processing. Thread-based multitasking, that is, multi-threading. It means multi-threading, sir. Today, our topic is multi-threading. Before multi-threading, I'm talking about multitasking. Multitasking means what? Executing several tasks simultaneously is called multitasking. Executing several tasks simultaneously is called multitasking. There are two types of multitasking are there. One is process-based multitasking, that is multi-processing. Next one is thread-based multitasking, that is multi-threading. Okay. So what is the difference between process-based multitasking and thread-based multitasking? That means multi-processing, multi-threading is what? So executing several tasks simultaneously, where each task is a separate independent process. Look at here. Executing several tasks simultaneously. Just observe here. Executing several tasks simultaneously, where each task is a separate each task is a separate independent process. Independent independent process is called independent process is called process-based multitasking. Process-based multitasking, we can say that. Process-based multitasking. Executing several tasks simultaneously, where each task is a separate, independent process, is called process-based multitasking, we can say that. So example I'm taking. Okay, example. What is the example? While typing Python program, okay, just assume that. While typing Python program in PyCharm editor, okay, in PyCharm editor, behind the scenes, I'm going to download a file from download a file from computer. Download a file, and while downloading the file, so for example, I have a GoToMeeting software with me right now. GoToMeeting software also is going to work for recording your session. So look at here, how many tasks I'm doing parallelly. Typing Python program in PyCharm editor. At the same time, I have just given a downloading a file from same computer. And also for your meeting, for your session, GoToMeeting recording is going to take place. So how many tasks are running at this moment? Same. 3 tasks: typing Python program, downloading a file behind the scenes, and GoToMeeting is software is recording your all these things, audio, video. Yes or no? So our operating system will provide separate process for typing Python code in PyCharm editor, and also it will provide separate process for downloading a file, and also it will provide a separate process for GoToMeeting audio video recording, all these things. So how many processes are going to be done? 3 processes. Process 1, process 2, process 3. So this process will provide who? Who will provide this process? Operating system will provide. So executing several tasks simultaneously means parallelly. These 3 tasks are going to be parallelly. Where each task is a separate independent process. Each task is a separate independent process is called process-based multitasking. Separate independent process means what? This process is separate. Typing code in PyCharm editor, downloading a file, this process is separate. GoToMeeting software, this process is separate. These are all separate or not? Yes. So these are all separate processes. This is called process-based multitasking and multiprocessing, we can say. But this type of multitasking is best suitable for operating system level. Okay, this type of multitasking, this type of multitasking, this type of multitasking is best suitable for operating system level, OS level only, operating system level. This type of multitasking is best suitable for operating system level, sir, OS level only. Got my point? So now coming to the thread-based multitasking I'm talking. So thread-based multitasking. Thread-based multitasking means what? Just observe here. Executing several tasks simultaneously, where each task is a separate independent process of the same program. Independent process of the same program which we are running is called thread-based multitasking. And here each independent part is called one thread. Here each independent part is called one thread, sir. Here each independent part is called one thread. Each independent part is called what actually? One thread, separate thread. This is separate thread, sir. Each independent part is called one thread, we can say that here. Executing several tasks simultaneously, where each task is a separate independent process of the same program is called process-based multitasking. Here, each independent part is called one thread. We can say that each independent part is called one thread. So this type of multitasking is best suitable for what? Programmatic level. So in our Python programming, this type of multitasking best suitable for programmatic level. Programmatic level only. So we are going to use this type of multitasking only. What type of multitasking? Thread-based multitasking we are going to use. That is what multi-threading concept we are saying. Multi-threading. Thread-based multitasking, that is multi-threading only we are saying. Okay. So whether it is process-based or thread-based multitasking, no matter, the main advantage of multitasking is to improve performance of the system by reducing responsive time. To improve performance of the system by reducing what? Response time only here. Okay. So this is the main purpose of the multi-threading purpose. Simple logic I'll tell. Multi-threading concept is just for multitasking. Multitasking means what actually? At a times, parallelly, we are doing multiple tasks. That is called multitasking program. So multitasking, whenever we do, then we will save a lot of time, obviously. Suppose while watching TV, I want to drink a coffee. So I need not to spend separate time for drinking coffee and separate time for watching TV. So both at a time parallel I can do that. I can spend only same time for both tasks. So I can finish work quickly here. So here also in a programmatic level also in Python also, if you have a two functions or three functions or multiple functions in same program. So all functions, if you execute parallelly, then execution time will be reduced. If you execute one by one function, one after one, then execution time will be increased because one function completely execute, then only after that we have to start one more function execution. That is time taking process. So multitasking we can do two ways. One is process based multitasking, that is multiprocessing. Thread based multitasking, that is multi-threading. Difference between process based multitasking and thread based multitasking is what? In process based multitasking, that is suitable at operating system level. Our operating system will provide separate process for typing Python code in PyCharm, and also it will provide separate process for downloading a file from computer, and it will also separate process for GoToMeeting software, audio and video recording purpose. And if there is any process is disturbed or due to some memory issues, other process will not be help, and other process memory cannot be allotted to some other process which is going to be trouble. This is problem with operating system. This is only operating system level it will work. But in this multi-threading program, what is the happening? No, if multiple threads are running for your same program, if any other thread is going to be get disturbed, okay, so means memory issues, then other thread memory can be shared. So memory can be shared together with the thread, multiple threads in a program. But in operating system, memory will not be shared. Each and every memory separately, which allotted for which process, that process only it has to be run. That is the multi-threading programs and process-based threading process-based multitasking and thread-based multitasking difference. But we are talking about multi-threading only because in our program we are going to divide our task into multiple threads where each task is separately target one function. That task is called what actually? Each independent part is called one thread, we can say. Executing several tasks simultaneously or parallelly where each task is a separate independent process of the same program is called thread-based multitasking. Thread-based multitasking, where each independent part is called one thread, we can say that. That's what multiple functions are there, multiple executions are there. So that's what multi-threading concept is there. This type of multitasking is best suitable for programmatic level, I can say that. So whether it is a process-based multi-threading or thread-based multi-threading, no matter, our main target is the main advantage of multitasking is to improve performance of the system by reducing responsive time, I can say that. Okay. The main important application areas of multi-threading are to implement multimedia graphics, to develop animations, to develop video games, to develop web application servers like this. In this context, we can use multi-threading program. So Python provides built-in module to work with multi-threading programs. The module name is called threading module. We have to import threading, sir. Import threading. This is the module which will provide by Python to us to work with multi-threading programs only. And in Python programming, in Python, every program, this is important, in Python, in Python, every program is having one thread that is called main thread. In Python, every program by default, contains one thread. By default contains one thread which is nothing but main thread, which is nothing but main thread, we can say that. In Python, every program by default contains one thread which is nothing but main thread, That is the case. So let's check out every program is having one thread by default main thread or not. How do we check? So this is the module which will provide Python to work with multi-threading programs. Even so many programs I discussed in my previous examples, previous topics, but every program, this Python db1.py also by default executed under one thread, main thread only. Let me check that our program is executed or depending on one thread, that is main thread or not, how to find main thread name, all these things. We'll look into simple example starting. So I'm writing one simple program by adding the Python file here. Let's go to new and Python file. My file name is thread1. It's my program one, especially for multi-threading. So this thread1.py also executing under one thread, main thread I'm saying. So how to do this? Just import threading. Python provides built-in module called threading module if you want to work with multi-threading programs. But currently I want to find that this program is executing on which thread. Okay, so just I'm giving description current executing thread. Current executing thread, we can say that. Current executing thread is what thread? So threading is a module name. Current executing thread is what actually? Threading is a module name. Dot current thread is a method name. Dot get name is a function name. So this is threading, module name, method, and sub method. Get name is there. But this get name is striking out. That means in future upcoming version, there may be chance to remove this get name method. They are showing warning also. You can see this. We will get some warning. So what are the warnings? Deprecation warnings you will get. Now you can see current executing thread is what? Main thread. Our program is executing. This line is giving the result. But along with the result, they are saying that warnings. We have seen many times in my previous examples also warnings. Warnings are very common in IT industry. So that warnings are that because just notification, okay, notification, they are giving notification, that is deprecation warnings are there. How to avoid warnings, you know that already. We discussed in my previous examples. Import warnings module you have to include. So warnings dot filter warning is there, and there is a ignore text we have to use. And which category of the warnings you want to ignore, that category you have to mention. What is my category right now? Deprecation warning is there. So deprecation warning I want to ignore. So these two lines are include if you want to ignore these warnings or you want to make clear your output window. So avoid disturbance by getting warning every time. So you can avoid that. So now this time you can say this is my actual program. This is just for warning avoiding purpose only included. Current executing thread is threading is a module name. Dot current thread is a method name. Get name is a main thread name is coming. So every time you can see if you want to set the name of the thread, can we change the thread name? Yes, we can change the thread name. How to change the thread name? Current thread. Sorry, threading is a module name. Dot current thread. Dot set name. Suppose here I'm changing the thread name from main thread to my thread. I'm changing. Once we change main thread to my thread, then automatically my thread is changing now. You can see this my thread is name is changing here. So let's check out whether this thread is changing from main thread to my thread or not. Let's copy and paste it once again so that you will get clearly here. Your thread is changing from main thread to my thread or not. You can easily find out here. How to find out? Let's run this. And I'm taking current executing thread is main thread only. After changing the name from main thread to my thread, your thread is now my thread only. The name is changing here. Get name is just getting the name of the thread. Set name is to set the name of the thread. But here one thing you can notice that every time we are using threading dot current thread, threading dot current thread like this. If you don't want to use threading module name every time, so better to import from statement only. From threading import star. This is the better option. So because the advantage of from threading import star implementation is what? No need to mention any module name at all. Directly you can use it functions. Without including module names, directly you can include functions only. Sir. Here you can see we are now you can see current thread dot get name. Once I run this, now you can see we got current executing thread, main thread, current executing thread, my thread. Both are working? Yes. This is just for showing an example whether every Python program is executing under one thread or not. I just want to show you. Okay. So it's very clear. In every program, internally one thread is under one thread is behind the scenes by default executing. That is called main thread only. We can say that this is the main thread by default. If you want to change the name of the thread, you can change the name of the thread also. Okay, this is one of the program here, thread one. But just observe here. Next, I want to show you the difference between single thread program and multi-thread program. Single thread means every program by default one thread will execute. That is single thread. What is the difference between single thread and multi-thread program? Okay, if there is no threading concept involved, then what will happen in that case? A program will execute one by one. Means how many functions we have included in the program, that many functions will execute one by one. Next, if that program converted into multi-threading means multi-threading means multiple threads are running. So you will find the differences. The main importance is what? I want to find the difference between single thread program and multi-thread program. How to find the difference between single thread program, multi-thread program? We will look into that once. So first I'll write one simple program here. Okay. After that, you can look into that. So whether this single thread program, multi-thread program, how it will work. Okay. Single thread program, multi-thread program, difference is what I will tell you. So now you can see I'm using threading module I'm not using. Okay. So just I'm taking square function, df square function I'm taking. Square of numbers I'm taking. Numbers means this function is going to take some numbers as input and it will perform the values for n. N means numbers. In numbers I'm taking. For n in numbers. Square of df square of numbers and for n in numbers. Now we can see I'm going to import some time module. Why time module? Just try to understand. Time module is required for calculating the time only. So let's go for n in numbers. N means loop variable. In numbers means here we have to pass number of values. Each number I have to perform the square. While perform each number the square, I want to make some sleeping time just 1 second. I want to wait so that you will understand clearly. So I'm printing here. Now you can see printing square is square is so what is that? N into n. Square is n into n. Now we can see df cube function I'm taking cube function numbers, cube of numbers. Now for n in numbers, time dot sleep of 1, time dot sleep of 1, print cube is what? Cube is n into n into n, n into n into n, like this. So numbers equals to 2, 3, 4, 5, 6, 7, 8, whatever it is. Just I'm giving numbers. And this is, I'm going to call the square function. Square function is expect numbers as input, and cube function also is expecting numbers as input now. Now after that, here you can see whenever I try to executing, just I create a square function with taking numbers as input, and in this numbers collection, every number I'm iterating for loop through. For every number printing after 1 second, I need to wait, and square is n into n. 2 into 2, 4, 3 into 3, 6, like that. And at the same time, cube function also is there, cubing for cube performance. And we are calling the functions. Cube function I'm calling here, square function I'm calling here by passing list of collection values as numbers input parameters. Let's run this one. This program is not at all executing under thread, means single thread only, main thread only will execute. Now you can see that by looking output, you will find whether this program is executing one by one or multiple tasks one by one. Like square function is executing first, then after cube function is executing. Look at here. It is very clear output. First square function is calling. After completion of executing square function, then immediately which function is calling? Cube function is calling now. So one by one executing or not? Yes. So even though if this program is executing one function after another function, I want to calculate how much time it is required to take. How much time? Okay. So how I can calculate? Just observe here. So time module is there, time module. Then here I'm not going to sorry, I'm going to be mention time object here. T is my time object equals to time is a module name dot time is a method name. Okay, time is a method name. T the time module. Time is a module name or method name here. This is, and I want to perform print done in done in done in print done in. How much time it is taking? I want to calculate. So I'm taking time module name, time method name. Hyphen T is a time object here. This is the time object. So this concept is for any program time calculation. How much time it is taking program execution purpose? I included just, you can see, import time module, and after that T is a time object, module name dot method name, and module name dot method name hyphen T means time object calculation here. Automatically time execution time will be calculated. You can see. So here one by one task is going to happen. Square function is calling first, then after cube function is calling. Just observe here, one by one task is going. One by one task is going. Yes, one by one task is going. Done in 14.17. Okay, how much time it is taking, sir? 14.17 seconds it is taking time. This is single threading program or multi-thread program? Obviously, it is single thread program only, because one by one task is going to do. Square function is doing separately and cube function is doing separately. One by one task is doing separately. So this is single threading program only. 14.1720 like this. This is time. Same, I am converting into this same program into multi-threading program, sir. How to convert this program into multi-threading program? Now you can see from threading import star. So it indicates that you are implementing this program into multiple threads. Multiple threads means not single thread, that is not main thread, multiple threads I'm using. So for executing square function separately, okay, one thread I want to create. For executing cube function separately, one more thread I want to create. So let's try to create multi-threading without calling the functions directly. Now I'm creating multiple threads here. T1 is my thread name. Thread is a built-in class. Look at here. This thread is a built-in class, which is coming from which module? Threading module. This is the module name. So thread is a built-in class, and this class is having a target attribute. Which function you want to call by using this T1 thread? Square function I want to call. But square function is having some parameters, like it is expecting numbers. I'm passing args is the attribute equals to numbers, means this is the parameter values, then comma symbol I'm using here. Now you can see comma symbol. So square function is expecting numbers. These numbers I'm passing as a parameters here. T1 is a thread name, thread object, equals to thread is a class. It's a built-in class. Target is an attribute. Which which function I'm targeting by using T1 thread? Square function I'm targeting. And this square function is expecting what? Actually args equals to numbers. So T2 is my next thread. That is thread 2, thread of target function I'm taking, cube function I'm taking here, cube, and args equals to what? Actually numbers, comma I'm taking numbers. So T1 thread, target equal to square, args equals number. T2 equal to thread, target equal to cube, args equal to number. So if you want to start the thread compulsory, we need to use a method called T1.start, T1.start, T2.start, I can say that, T2.start. Okay, then T1.join method is there. Join method is just for waiting one thread after another thread. So I will talk about join method in upcoming sessions clearly what is the use of join method. Right now I'm using T2.join method and so this program immediately converted into multi-threading programs. Here two threads are running, including main thread, three threads are running in general, three threads. You can see T1 is one thread, which is targeting to execute square function. T2 is another thread, which is targeting to execute cube function. And T1 started, T2 started. Along with these T1, T2, internally main thread also execute. Main thread means every Python program executed under one thread, I said, no, main thread that is. Now in previous example and this example, you can observe. In previous example, square function executed separately. And after completion of square function execution only, cube function is started execution. That's what it taking time actually 14.1720 like this only. 14.1720. Not my point, 14.1720. Now let's run this one. This time it is multi-threading program. Look at here how execution start. At a time square function and cube function both are executing or not. So time how much is going to be reduced? 50% of the execution time is going to be reduced. Previously the time was 14 point something. Now this time was what? 7.048 something. So half of the time, half of the execution time is reduced or not. Now once again you can say this cube is square is like this. But look at the output here. Output is not in regular format. It's a very common thing in multi-threading programs, sir, because multiple threads are going to be run parallelly. So you cannot expect the exact output. So that is common, but we can make the regular output also by using some techniques. The techniques names are called synchronization techniques are there. We'll discuss in our upcoming sessions how to synchronize the threads, how to arrange the output properly or regularly like this. So this example is just for showing difference between single thread programs and multi-thread programs. Single thread program, if we take how much time? 14 minutes, 14 seconds time it took to execute all functions. And whenever I converted this program into multi-threaded program, it took how much time actually? 14 seconds. It took 14 seconds. It took 7 seconds only. 7 seconds means half of the time we reduced here or not? Yes. So half of the time we reduce clearly here. This is the difference between single thread program and multi-thread program clearly here. To work with threading, compulsory threading module is required. In this module, there is a thread class is there. Thread class is there. T1 is a thread object. Target is an attribute. Using this T1 thread, which function you are executing, that function you should use as a target. And this function is expecting arguments, no, that is numbers I'm passing. Using T2 thread, target equals to cube, args equals to numbers. T1 dot start, T2 dot start here. T1 dot join, T2 dot join here. Done in time of life until like this. Okay, so this is the difference between single thread and multi-thread program. Okay, single thread and multi-thread program. And there are different ways to create threads in Python. In Python programming, there are different ways. Okay, what are the possibility? What are the different ways to create multi-threading programs? We'll see now. Different ways to create threads, thread in Python, thread in Python, thread in Python. different ways to create a thread in Python, sir. What are the different ways to create thread in Python? First way is creating a thread without using any class. Creating a thread without using any class. Next, creating a thread by extending thread class. Creating a thread by extending thread class. Next, creating a thread without extending thread class. Creating a thread without extending thread class, we can say that, without extending thread class. Creating a thread without using any class. Creating a thread by extending thread class. Creating a thread without extending thread class. This is. So 3 options are there. First option number 1, I want to create a thread without using any class. No class I'm using. Creating a thread by extending thread class. Creating a thread without extending thread class. First option I want to tell you, creating a thread without using any class. Okay. For that, let me go to another program here. Now you can see, go to new Python file. Thread 2 is my program name, and I'm just giving comment section. This is just consider this is an heading only. So creating a thread without using any class. Any class means, just observe here, I'm not going to use any class name like this. Okay, I'm not going to use any class. Just I have a function called f1 function. Okay, f1 function is there. And before that, if you want to write a multi-threading program, compulsory we have to use from threading import star. So def is a keyword of the function. f1 is a function name. In this function, I'm taking for I in range of 10 times I want to display here. So this program executed by anyway child thread only. So that's what I'm writing, child thread heading. T is my child thread object. Thread is the class. Target is what function we are targeting by using child thread T, F1 function. F1 function is don't have any parameters. No need to use any args equals to something. Okay, no parameters. Now T dot start, I can say that. T dot start. That's all. So look at here. Did I create in this thread2.py program any class like class keyword, class name like this? No, I have not created any class. From is a keyword, threading is a module, import is a keyword, star means everything. So we have a function called f1. In this function, just I'm using for loop, and this function execute by one thread, that is child thread T. So every time I'm using child thread like this. T equals to thread class target equals to f1 function. F1 only I'm taking. T dot start means what? Actually child thread dot start only. So this creating a thread, yes, I created thread without using class. I have not used any class. Okay, just I'm using, this is the thread class, but I'm not using any class means this is the meaning. No class keyword is there, no class name is there like this. Did I use any class? No class. So this is creating a thread without using any class. Now let's run this. We are getting child thread like this. How many times? 10 times. Because whenever thread started execution, this thread is targeting which function? F1 function. F1 function will execute happily like this. Suppose this thread2.py right now is having one function F1. F1 function is executed by child thread. But look at here, remaining part for I in range of 10. Print this part of the code is executed by which thread? Main thread only, because line number 13 and line number 14 is executed by main thread. Because behind the scenes, every thread is having one, every Python program is having one thread, no? That is called main thread. That is executed, main thread is executed this code only. And this part of the code, line number 6, 7, 8 is executed by child thread T only. So main thread is executing, child thread is executing. Main thread executing this program and child thread is targeting this F1 function. So how many threads are running? two threads are running. So just observe here, the output is not going to be regular. Main thread, child thread, main thread, child thread, like this. Now you can see main thread, child thread, main thread, child thread. First child thread is executed, again main thread, again child thread, like this. Output is not regular format, sir. Don't expect the output here. You can see this every time execution to execution, output is completely different option is there here. So if multiple threads present in our program, then we cannot expect execution order. That means we cannot expect exact output for the multi-threaded programs, because we cannot because the reason is here multiple threads are parallelly executing the code, so we cannot expect the exact output here. So the output will be different from every execution to execution, for every run to run. That is the thing actually. But we can arrange the multi-threading program output properly by using some synchronization techniques or the synchronization techniques. Okay, so this is creating a thread without using any class. Creating a thread without using any class. That's all about today. In tomorrow, we'll cover this creating thread by extending thread class, creating thread without use extending thread class, and thread synchronization mechanisms are there. There are so many concepts are there, functions also there. So it will take two more classes for threading finish. Okay. Next, what I'm trying to do, I have some simple concept are there, pending concept, generators concept is there, decorator concept is there, logging, assertion, pandas, matplotlib. So these are all concept I'm going to finish by this weekend, and next immediately coming Monday, same 7 o'clock only, I'm going to start. Okay, I'm going to start a new batch, that is Monday 11th, online batch, Django morning 7 a.m. I'm going to start. Okay, be ready for that. Those are looking forward Django also. So I'll start immediately on Monday, July 11th, 7 a.m. I already announced the batch. So please wait for that. This week I'll finish this your Python, and definitely Monday onwards you can able to continue on same time Django only. Okay. So we'll see tomorrow again. And those who are attending my 8 a.m. Django current batch, you can join that 8 a.m. only, no problem. But those who are asked previously 7 a.m. only comfortable for Django means that's what you people only. For you people, I announced new batch coming week. Please utilize that.